Lesson 6.6, talking about permutations for the most part, except for these first two questions don't fit into permutations. These are just the counting method. Could you all do me a favor and like totally put a little note right here? When we use this counting method is when repeats are allowed. Put that down for me, please. For the counting method, you can repeat numbers. So Yolanda, she's our special guest, she shows up a lot in these, is forced to create a passcode for her phone, right? You know what I'm talking about, like the passcode to get into your phone, right? It must be 4 digits long, consisting of only numbers 0 through 9. How many different passcodes are available? Let's talk this. Can she use the same number more than once on her passcode? A lot of people do. So repeats are allowed. Are you with me on that? Here's how we'll make this easy. We're going to draw blanks, right? How many digits is her passcode? 4 digits, 4 blanks. Boom, 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 boom. 4 digits, 4 blanks. Draw on some blanks. These have to be numbers 0 through 9. Don't get tricked. There are 10 numbers there, right? 1, 2, 3, 4, 5, 6, 7, 8, 9. And who's the 10th one? 0. Are you with me that there's actually 10 numbers? So how many choices does she have for her first digit? Out of the 10 numbers, she could choose any of the 10. Would you believe she's got 10 choices for that? She get a repeat on, like if she chose 5 for the first one, can she choose 5 for the second one? So how many choices does she have for the second one? 10. The third one? 10. And the fourth one? 10. And here's the cool move. We multiply all these numbers together. It's 10 times 10 times 10 times 10. How do you feel about 10,000? There are 10,000 different passcodes she could possibly have. The craziest thing about it is we all live in a world where passcodes are very common. It is amazing how fast you could probably figure hers out, because how common is it that people do 1, 2, 3, 4? You know what I mean? How common is it that people do like 5, 5, 5, 5? You know, they use the same digit over and over and over to make it easy on themselves. Please, as a young person in today's society, the more complicated you make your passcodes, the harder it is to get hacked. Does that kind of make sense? Because there's 10,000 different choices. Why keep it such a simple one? 1, 1, 1, 1. You know what I mean? It's like, come on, man. You know, especially when you start getting into your computer and things like that as you get older. Let's talk about a license plate. It's consistent of 3 letters, so I'm going to do this. 1, 2, 3. 3 letters right there. And then 3 numbers. 1, 2, 3. How many different license plates are possible? My question is, are repeats allowed? You guys all probably have driven, or at least probably have a car, maybe not have a car, but you know what I'm talking about with a license plate. Could a license plate be this? AAA 000. Are license plates allowed to repeat letters, yes or no? Yes, that can happen. So here's the thing. The first ones are letters, right? In the English alphabet, do you know how many letters there are? 26, baby. There are 26 choices for the first part of that license plate. It could be an A, it could be a B, it could be a C, etc. Are you with me on that? How about the second one? Since repeats are allowed, how many choices for the second one? 26, right? We didn't have to remove any. And the third one, 26, right? There's your 3 letters. The other ones are numbers though, right? So 0 through 9, aren't there 10 numbers? And you can repeat them. Guess what we do with all these? We just multiply them all together. So that's 26 times 26 times 26 times 10 times 10 times 10. And that's going to be a big number. I like to put commas in that bad boy. So I like write it down. It's like 17556 missed a 7. 17576 and then go back every 3 spaces and put commas. I missed something here. Let me try that again. Isn't it 17576 That's what it was, right? So like over 17 million. It's kind of cool. Like I'm a nerd like this. This is the Kansas license plates up till this year, right? Maybe it was last year. But the Kansas license plates had 3 letters on it and 3 numbers. And have you noticed that we got new license plates this year? They added a number, right? They totally added a number. Now there's 3 letters and 4 numbers. How many more license plates did they create by adding a number? Like they had 17 million license plates possible in Kansas. How many more did they add by adding 1 more number? Times how many? 10. Didn't they add 10 times as many license plates that they did just by adding a digit to it in that case? That's totally crazy. Just like I showed you with the Price is Right, like where they only had to choose for those 3 numbers, pick 2. By putting that extra number on there, holy cow, did that create a lot more possibilities. But these right here are the counting method. The only time we do this is if you are allowed to repeat a digit. The permutations is the real part of this lesson. That's a fancy word. Here's the main thing that we'll learn is that the order matters on these guys. But they don't get replaced. So Rita is forced to make a passcode on her phone. It must be 4 digits long, consisting of only numbers. But the weird part is this phone won't let her use the same digit more than once, right? So we'll still draw blanks. 1, 2, 3, 4, because it's a 4-digit passcode. And on the first number, how many choices does she have? 10. Then she had to choose one of them, right? Let's just show she started with a 7. Would you believe since she can't use 7 again, she doesn't have 10 choices for the second number. How many choices does she have? 9. And it doesn't matter if she chose 7 first or 3 first or 2 first. That one choice can't be chosen again, right? So that's why it went down to 9. Now she's chosen 2 numbers. So how many are left for the third guy? 8, right? And then the fourth digit, there's only 7 choices left because you're not allowed to repeat. So we just multiply them together. 10 times 9 times 8 times 7. And there's only 5,040. That's fascinating to a nerd like myself because if you could repeat the digits, you had 10,000 possible passcodes. If you can't repeat the digits, it's almost half as many, right? It's only 5,000 plus like passcodes. That's nerdy fascinating to me. Make it a playlist, like on Spotify, right? You know, so Dave's going to do it. He's got 10 songs that he wants to put in it, and only those 10, right? He's like, these are my 10 songs. How many ways could he arrange the playlist? Like which song plays first, which song plays second, which song plays third, etc., right? Instead of shuffling. So here's my question. Are repeats allowed? Is he going to put the same song in there twice? No, right? So he's got 10 songs. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Holy cow, that's a lot of blanks. He's going to put 10 songs in the playlist. How many choices could he put for his first song? Well, he will only have 1 song, but he can choose out of how many? 10. Like, you know, if he had all these songs, any one of them could come first. I'll just use silly little Miley Cyrus, for example. Let's say it was all about Miley Cyrus. If Party in the USA was in that list and he chose that first, would you believe now he can't choose Party in the USA again? Are you with me on that, right? So how many choices does he have for the second song? 9. How about the next song? 8, then 7, then 6, then 5, then 4. Time out. Then 3, then 2, then 1. Do you have any interest in typing all that crap in your calculator like that? 10 times 9 times 8 times 7 times 6. So let me show you a faster way to type that in. This, let's write it down. When you take a number that was 10 and you multiply it by every number 1 less than that all the way out to 1, it's called factorial. And the way you write it in math is an exclamation point. That's called 10 factorial. And how do you punch that in the calculator? If you have one of mine, I'll show you. Then I'll show you how to do it on Desmos because I put the Desmos calculator into all the questions because your phone ain't going to do it for you, right? So we'll type the number 10 first because that's what we want to do. Where is the exclamation point at? You see the math menu? It's like the 3rd button down right here that says math. Hit that math button. And then you got to scroll over to the right. Up at the top, you see math is like in a dark black box. I got to scroll that over to the probability menu, right? And then you see the 4th option is that exclamation point right there. So I would go down to the 4th guy and get that exclamation point. And that factorial will multiply 10 times 9 times 8 all the way down to 1 in that case. So 3, 6, 2, 8, 8, 0, 0. Then go back and put commas. How do you do it on the Desmos calculator? You type the 10 first, right? And then can you see like this little bar that says the main function right here, then there's ABC, and then it's this function menu. If you hit the function menu, there's your exclamation point right there, right? So it's under the function menu. I even typed that out into the box right there, and you get the same number right there. That exclamation point is called a factorial. It's used when you want to take a number all the way down to 1. So just for fun, is 5 factorial, like what does that mean? It means 5 times 4 times 3 times 2 times 1. Are you with me? It goes all the way down to 1. Like 7 factorial is 7 times 6 times 5 times 4 times 3 times 2 times 1. Are you cool with what a factorial is? A race is going to consist of 10 runners. Ooh, 10 people. The first 3 runners will receive an award. First place, second place, third place. Are you with me on that? You know, the first 3 runners will receive an award. How many different ways could that possibly line up? Let's do blanks again. How many awards are given away? 3. Boom, boom, boom. All right? First place, second place, third place, if you want to put a little bit of like extra help. It's just whatever. This is the race. How many people are in the race? 10? So if everyone had a fair chance and nobody's better than anybody else or anything like that, how many possible people could take first place? All 10 of them. Everybody's got a shot. But would you believe somebody finished first place, right? So after that, how many people could take second place? 9. And then the last one, how do you feel about 8 people being able to take third place? Timeout. Is this a factorial situation? Can I use the exclamation point? No, because it doesn't go all the way down to 1, right? So we can just multiply it out. It is 10 times 9 times 8. And that's 720 different ways that race could finish. So a group of 20 students ran for Stuco office, you know, like president, vice president, and secretary. How many ways could they be selected? Your blanks is how many spots there are. Would you believe there's only 3 spots? President, vice president, and secretary. Cool? See if you can put the right numbers into the blank. How many people could be president? Then once the president is selected, how many people could be vice? And then once that is selected, how many could be the secretary? And check it with mine. How do you feel about those 3 numbers right there? You know why it kept decreasing? Because repeats were not allowed. Like you could not be president and vice president at the same time. Like they won't allow you to repeat yourself. So we multiplied those together. 20 times 19 times 18, baby. 6840, is that what you got? Cool. So then here, I showed you on the Desmos calculator about how to do factorial. There is a fancy way to do the permutations also, and we'll show you when that's necessary. I don't like to use it if I don't have to, but I'll show you. Sometimes it's just, you got to do it. An elementary school has a class of 8 students who want to line up for lunch. How many ways can they be arranged? Let's talk about this. All 8 students, you know in elementary school they make you line up all the time before you go to lunch and all that junk, right? You know, so it's like, are all 8 kids allowed to go to lunch? Yes or no? Yeah, they're all going to go, right? So, and then if they arranged them, how many people could go first? Well, 1 person, but how many choices do I have for that 1 person? 8 of them, right? And then he's first or she's first, right? Then how many people would be second? 7. My question is it going to go all the way down to 1? Is this a factorial situation? Would it be 8 times 7 times 6 times 5 times 4 times 3? So what you do is this, 8 factorial, right? 8 factorial. So to punch that in, you type the 8 first, then you go to the math menu and scroll over to probability, and it's option 4. And get that exclamation point. Or if you were on Desmos, again, you would clear this out. Don't know how to do that very well. So you would type, you have to go back to your main function and hit 8, and then you go to function and hit the exclamation point. Did you get 40,320 back on that? 40,320. Can you just imagine trying to do that? Like, just 8 kids in class. Let's rearrange you, right? You know, and it's just like, holy cow, we could do that over 40,000 different ways. Wild. But here's the big one. A password must be 8 characters long, made of only lowercase letters, and cannot use the same letter more than once. How many passwords are available? So since they're letters, and they're only lowercase, how many options do we have? 26. Is this a factorial situation? Am I going to go 26 times 25 all the way down to 1? Am I going to have 26 different numbers in my, or excuse me, letters in my passcode? No, it's only going to be 8. Are you with me on that? So This is totally a blank situation. I'm not keen on drawing a bunch of blanks if I don't have to. 4, 5, 6, 7, 8. Are you with me on that? Like 8 blanks is a lot of stinking blanks. And it's 26 times 25 times 24 times 23. So we're going to use this cool little function with me. It's called NPR. And P stands for permutation, right? So here's what I'd like you to write down. You write down NPR. And here's what N stands for. Total options. These are the letters that are lowercase. What was our total options? 26. It's not quite the 8, right? There's 26 options available. Are you with me on that? Then the P will be in the middle. And then how many spots are there? How many blanks would you have drawn? 8. 26, choose 8. Are you kind of with me on that? 26, choose 8. How do you do that on this calculator? Clear all this stuff out. Type 26 first. Then you go back to that same menu we were in, hit the math key, go over to probability, right where the exclamation was, but you see option 2 says NPR up there. The P stands for permutation. So I'm going to select this option right here. And it's going to make me put that second choice in there. Wasn't there 8 digits in my passcode in that case, right? So it's 26 times 25 times 24 times 23, all the way, 8 times they're going to draw. They're going to draw the 8 blanks. Did you get this big-ass number right here that has an E with it, right? Been a while since we've seen the E. That E is scientific notation, means times 10 to the whatever number is next to it, 10th power. So what we're going to write is 6 point, what would you round that to, that nasty decimal, 6.2 or 6.3? 6.3 times 10 to the 10th. That E took this spot right here, times 10. Our calculators don't like to put times 10 to, they put this E. And then why did I put a 10 up there? Because that's times 10 to the 10th power. What that really means is I would move this decimal 10 places to the right, to where it would be 6, 3, 1, 2, 3, 4, 5, 6, 7, 8, 9 of those zeros right here. That's how many stinking options you have, 63 trillion, I think, options in that case. That is a huge number. So please don't get freaked out if you get an E with that guy. It's just a really big number. How do you do it on the Desmos calculator? It's a little backwards. So let me kind of clear this out. You got to go do this first. You got to hit your function button. You see the NPRs in the lower left-hand corner. And then you just do 26. And then you got to put a comma 8. So they make you kind of type it in as the NPR first, then the 26, then the 8. And you get the same number back in that case. And then the last one of the day, I put the bingo troll here for a reason. Not sure if you've ever seen these. Back in the 90s, these troll dolls were a big hit. And I don't know why that all these crazy old ladies that play bingo, no offense to if that's a family member of yours, they would bring them for good luck, right? And they would blow on the hair and do all this crazy stuff. But here at the bingo house, they made a rule. They say, yo, Yolanda, you got way too many troll dolls on the table. She's got 18 of them. Too many. You're blocking the spots off for everyone else. So we're only going to allow you to have 4 troll dolls on a table. That's just a rule the bingo house put in. So would you believe that when she's playing bingo, she has 18 dolls and she can only choose 4 of them? Are you with me on that? So what you could do is this, 18P4, if you wanted to. But since there's only 4, I'm kind of nice on the blanks in that scenario because it's not that many blanks. It's 18 times 17 times 16 times 15. Either one of those works. When would I use this wacky thing? When I got to draw a bunch of blanks. When I got to draw a bunch of blanks. Are we cool with that? So let's go back